Good morning, everybody. Welcome to the RCN webinar. We will get started in a couple minutes and we'll just wait for our attendees to trickle in. Good morning, everybody. We'll get started in one more minute. Okay, we're going to go ahead and get started. So Happy New Year, everybody. Welcome to the RCN monthly webinar. I'm Allie Boehm, and I'm going to do a quick introduction here. And it's really nice to see so many familiar names for the attendees. Some of you we've gotten to see in person over the last month. So today we're really excited for our two sets of speakers. We have Rafi and Carolyn from Canada. That's a very informal introduction of their positions, both faculty at University of British Columbia and Queen's University in Canada. And then we'll have Sílvia Monteiro from Portugal, and we're very grateful for her joining from Europe, talking about dengue and chikungunya viruses in wastewater. Before we begin, I just want to plug our monthly journal club, also our webinar nomination link and our email list, and Kyle has just put those in the chat for you. A reminder of how the webinar works: attendees can put questions in the Q&A, and then we will be moderating the Q&A session after the speakers present. One more announcement is that Sarah Philo, who was formerly a postdoc, is now working on potable water reuse, and she has a report coming out that she is interested in sharing with all of you, which we will allow her to use the email list to do that. So with that, I'm going to pass it over to Carolyn and Rafi for the first presentation.
Great, let me just get set up here. Okay, so good morning, everybody. Thank you to Ali for the invitation to present. My name is Rafi Arefin, and I'm an assistant professor at the University of British Columbia in Vancouver. I'm here with my colleague, Carolyn Prouse, who's an assistant professor at Queen's University in Kingston, Ontario. Together, we run a joint research lab investigating the social, political, and economic dimensions of biosecurity and biosurveillance initiatives. So for the past few years, we've worked to analyze the increased number of private firms in the field of wastewater surveillance. We've done so with the aim of understanding the extent of the private market's involvement and what effect this has had on the science and public health governance. In March 2022, at the inaugural Wastewater Disease Surveillance Summit in Ohio, the CDC presented a 2-year-in update on the National Wastewater Surveillance System, which was at the time surveilling an impressive 30% of the US population. The CDC, of course, wanted to expand the system, And they said they would do that through commercial testing contracts and private partnerships. A few months after this summit, the CDC announced a large contract with BioBot Analytics. Private contracts were, of course, not new to News. Since its formation in 2020, News has worked with established and startup biotechnology firms. But more recently, in October of 2023, the CDC announced that it was switching providers for its commercial testing contract away from BioBot to Verily Life Sciences. So why has Verily become interested in wastewater surveillance? Verily is increasingly turning to biosurveillance initiatives like wastewater surveillance, as other sectors in health data and technology are not performing as expected. So we return to these moments to show that the expansion of wastewater surveillance in the past 4 years has depended upon and helped to spur a private market in the field, really taking shape during a public health crisis. Private involvement has often been justified because it fixes a problem of public capacity, the idea that public networks just don't have the resources, people, or technologies to really do this work on their own. But private involvement also introduces its own set of distinct issues, which we'll discuss today. This is to say that in addition to like the science and the public health policy, the field of wastewater surveillance is also increasingly influenced by another factor, what public health scholars are calling a commercial determinant. According to the World Health Organization, commercial determinants of health are a key social determinant and refer to the conditions, actions, and omissions by commercial firms that affect health.
Our work is driven by 2 research questions. So first, we want to understand the emerging economic actors and practices of wastewater surveillance. And second, we want to understand how multi-institutional public-private partnerships are transforming public health governance. To answer these questions, we've carried out interviews with over 30 actors in wastewater surveillance in North America, the Middle East, and South Asia. We've attended conferences and workshops, and we've reviewed academic and industry papers, reports, press releases, websites, and databases. And we found that private firms, in partnership with public entities, are framing wastewater data as vital to public health, but also valuable as a new area of biotechnology growth. We argue that as governments, academic institutions, philanthropic organizations, and industry help create this private market in wastewater surveillance, they also create these new multi-institutional spaces of governance that are increasingly profit-driven, that are black-boxed, and that are experimental, with possible uneven impacts on public health governance. While these private actors may not intentionally seek to cause harm, we know that, we argue that the involvement of these actors may have important but overlooked consequences that require further scrutiny, which is what we're trying to do. So here's an outline of what we will do today. First, we're going to share findings on the scope of the private market and the interfaces through which firms work with public and nonprofit entities. And then we point to the impact of these transformations and end with some points for further discussion. An effective wastewater surveillance system, as many of you know, is this complex dance between utilities, microbiologists, public health officials, policymakers, and many more actors and entities. Such a complex transformation of sewage into data, policy, and then action means that there are lots of steps and interfaces where private firms can enter to provide services where overburdened or capacity-strapped public health systems and utilities can't currently meet needs. In the race to roll out and expand wastewater surveillance in 2022, we saw an array of private firms forming this bustling wastewater surveillance market. And through a global landscape scan, we found that since 2020, over 50 private firms spanning North America, Europe, the Middle East, and South Asia are dedicated to or offering wastewater surveillance services and products. Of these over 50 firms, the newer firms of first category that we're thinking of were predominantly integrated wastewater surveillance solution companies. And prominent examples of these, as many of you will know, include BioBot, Ginkgo Bioworks, Concentric, and Verily Life Sciences. The second major category of companies we found include established life and environmental science companies and commercial testing labs. And these firms include QIAGEN, Luminultra, Biorad, and Pace Analytics.
So through our landscape scan and interviews, we found that really in the wake of the COVID-19 pandemic, an array of multi-institutional relationships emerged to rapidly develop and expand wastewater-based surveillance. We found that connections intensified and frequently shifted between multiple private firms, public entities, universities, and nonprofit foundations. So to make sense of this complex emerging network, we categorize these relationships into three interfaces. Now, the first interface is between utilities, public laboratories, and commercial testing labs, and established life science firms. This relationship was not new, but has expanded in distinct ways to create new demands and markets in wastewater-based surveillance. For example, US-based commercial testing lab Pace, which claimed to be the first commercial lab to offer SARS-CoV-2 RNA testing in June of 2020, noted that their ability to kind of quickly pivot their capabilities to COVID-19 wastewater testing was indeed a function of their long-standing relationships with water and sanitation utilities. Private firms often took an active role in fostering new markets and spurring demand for wastewater surveillance labor and technology. Biorad, for example, created a program called Roadmap with the stated aim of, quote, assisting state, local, tribal, and territorial entities seeking government funding for enhancements to their ongoing wastewater surveillance and pathogen detection efforts. So the emergence of wastewater surveillance in an infectious disease crisis meant that many of these firms could start to sell what were previously life sciences equipment and technology, like PCR and sequencing services, to their already existing environmental and water quality clients in the public sector. A second and more recent interface of public-private partnerships is the relationship between governments and wastewater surveillance biotechnology firms, the later often supported by venture capital. So actors at this interface include BioBot, Ginkgo Bioworks Concentric, Cando, and KrakenSense. Now, all of these firms either emerged from universities and/or received significant public funding to develop their services and products. A third and final interface exists between foundations and professional societies, providing direct support or acting as intermediaries between private firms and public entities. This interface became especially important in creating wastewater surveillance programs in low resource settings in urban areas in the global south and rural areas in the global north. These actors include institutions such as the Rockefeller Foundation, the Water Environment Federation, and Bloomberg Philanthropies. While many of these relationships brought surveillance to places that desperately needed the capabilities, the temporary nature of such funding meant that without guaranteed profit, firms were likely to leave and foundations would move on to different priority countries and different priority areas. Now, across all of these three interfaces exist connections between all kinds of private, public, and nonprofit entities in wastewater surveillance. These relationships have spurred a really complex ecosystem of public-private, private-private, and nonprofit public-private partnerships, really rendering what we're calling wastewater surveillance as this multi-institutional space.
So a key purpose of our research has been to understand what this multi-institutional space and these multi-actor public-private relationships mean for public health governance. And so through our work, we have identified three emerging trends of potential concern. First, with the expanding private role, surveillance activities are increasingly driven not only by public health concerns, but also by this commercial motive. The commercial motive has pushed the expansion of surveillance targets and also increased the speed and geographic precision of detection. So as governments, for instance, declared an end to the emergency phase of the pandemic, companies such as BioBot and others are returning now to marketing their services for the detection of high-risk substances such as opioids, and assay and diagnostic firms are advertising technologies to detect infectious disease from Mpox and norovirus to RSV and Ebola. And private companies are also proposing methods to surveil non-communicable diseases like obesity. In addition to these new targets, firms are also pushing the scale of detection, offering employers the ability to surveil at building level, so at these increasingly smaller scales. We argue that such initiatives, when privately driven, may undermine existing World Health Organization and other surveillance guidelines. So currently, the bar for justifying large-scale surveillance has often been set pretty high so that programs maintain community trust and operate in a transparent and ethical way. Such standards encourage clear definitions of program scope, goals, timeframe, and defined community needs. When commercial interests are, in part or whole, driving the expansion of targets or this precision of testing, these fundamental principles in public health surveillance are potentially under threat. Second, public and private entities tout the potential of wastewater surveillance to offer a transparent view into population health without expensive invasive testing or the biases that are often seen to plague access to traditional diagnostics. But increasingly, as private firms enter the field, surveillance processes are becoming proprietary or opaque. This is happening at multiple scales. For instance, News contracting with GT Molecular to create assays and panels for the public system. Contracting key aspects of the pipeline therefore raises concern, even amongst many of those scientists and public health officials that are doing the outsourcing and that we were interviewing. So the political process of creating and then making policy recommendations from this data is increasingly being black boxed, as our interviewees called it. In one US state, for instance, a public official highlighted her suspicion of turning over sewage samples to private firms or using proprietary sample to answer machines. She explained, quote, "I have an issue sometimes that some of those private firms are, oh, it's a black box. They'll say, trust me, it's magic. We put the sample in and the results come out. And sometimes they're very reliable and very ethical, and it does work, and it does give you appropriate results. But sometimes I don't know how you get from point A to point B. So until you can describe it to me or show it to me, you can't use that." That became an issue. This black boxing means that communication between scientists, utilities workers, and public health decision makers is often curtailed or can be absent altogether, reducing the often slow and multi-actor governance process into a single automated process or an out-of-house service. In one jurisdiction that outsourced testing, a utilities director lamented this loss of in-house testing by explaining, quote, "There's just much better communication there when the work is done in-house," end quote. A municipal official in a different state made an argument for not contracting surveillance to private firms because, according to them, it's only the local, in this case, the municipal government, that can understand on-the-ground issues and build trust with the community. They said, quote, "I think you need to be closest to where the issue is. It's not at the state level, it's not at the county, it's at the local. It needs to stay in the local government who knows the people best." When asked if this municipality had ever been approached by private firms offering services, they expanded. Quote, "Yes, can you give us the data? Can you give us your samples? We are inundated. 2021, we were the sandbox. At that point, it was that fork in the road. If we either turn it over and someone gets to decide this, that I don't know or trust. They're trying to make money," end quote. Finally, the tools of wastewater surveillance are still in relative infancy when compared to other forms of health and environmental surveillance. And there therefore exists debate about how to effectively conduct surveillance and how this data should be used to govern. We found that in an emergency context, these lines between public health programs and experimental research programs have increasingly blurred, especially when private firms are involved. Some of our interviewees suggested that the testing of private firms' equipment and/or their technology might actually be guiding product and service uptake rather than clearly defined health needs of communities. And this testing occurred, in some cases we identified, on vulnerable populations. So a recent example of this kind of experimentation is Ginkgo Bioworks' partnership with the Ukrainian Ministry of Health. The pilot program is testing the efficacy of the company's biosecurity platform in what is an obvious crisis setting, being war. The pilot is notable in its ambition, but it also comes at the specific financial juncture for the company. So industry reporting noted, quote, "The partnership announcements come a week after Ginkgo announced that it would meet its full 2022 revenue guidance on the strength of biosecurity revenues, as cell engineering revenues fell short of expectations," end quote. The experimental role of its biosecurity platform, deployed in this vulnerable setting of war, has therefore become a key part of the company's growth strategy. But war was only one setting where firms used this crisis to prototype technology for financial gain. We identified cases of incarcerated people in prison work programs who were testing prototype equipment in rural American facilities. We've seen the deployment of experimental field samplers in refugee camps. And we've also heard about the widespread validating and testing of methods in university dormitories, which are often not covered by tenants' rights and protections. The growth of private wastewater surveillance firms therefore represents this unprecedented shift in who carries out and governs surveillance in often publicly owned and operated sewers. Our research has shown that this shift presents concerning transformations in governance, including profits potentially displacing public health needs, the rise of these black box proprietary technologies, and the experimental rollout of prototyped technology among vulnerable populations. It's important to note, though, that following other scholars in the commercial determinants of health literature, we're not arguing for a field free of private firms per se. Rather, we're taking a health justice approach to evaluate the impact of these private firms in the field. And from our initial research, we would argue for a targeted role of private firms to work under the direction of existing public health units, where and when necessary, in order to ensure that they remain democratically and transparently governed. And this would set a standard for wastewater surveillance as an effective and equitable form of health surveillance in line with those guidelines that have already been published by the WHO and the Canadian Water Network, for instance.
So we've outlined large-scale concerns that really face this growing field. But to conclude, we'd like to outline a few ways we see these trends may be impacting the day-to-day work of practitioners like yourselves on this call. So first, in an increasingly private-public system, disputes over contracts like the Verily and Biobot situation may occur more often, leading to interruptions in data or issues in comparability of data over time and over contracts. This dispute and these issues can possibly undermine the social and political legitimacy and reliability of the data itself among policymakers. Second, as many of these firms started in universities or rely on the basic science discoveries of academic laboratories, they often use these insights without necessarily sharing the benefits, financial or otherwise, back with university researchers or the public sector. Third, at the same time that public health budgets are being cut across North America, university administrations are also encouraging community or policy-engaged research and action. Our own work as professors and the work of our graduate students is increasingly applied to help fill gaps in government services or government knowledge. Now, while this kind of action-oriented applied work is, of course, often rewarding and exciting, it can also displace the time and resources necessary for basic science research and questions. So instead of allowing kind of the private sector to replace this public capacity gap, we might consider lobbying and voting for politicians who believe in keeping public health as a public enterprise. Finally, with the increased reliance on private firms for the assays and other diagnostics materials, proprietary formulations are expanding. And this represents, I would argue, a shift in the wastewater surveillance field that was a vanguard in the sharing of knowledge and techniques across sectors and institutions openly. So this trend may pose a threat to the democratic and open science that really characterized the early expansion of wastewater surveillance in the early days of 2020. So to wrap up, we introduced these last few points as really a place to start discussion. As social scientists, these are the kinds of concerns we hypothesize from our own qualitative work, but we'd love to hear from you all if these resonate or if there are other kind of more everyday concerns that come up. So thanks for listening.
Great. Thank you so much, Carolyn and Rafi. And we have some questions coming in, and a reminder for all the attendees, if you have questions, to put them in the Q&A box. So the first question came from Dan Garrity. Are you noticing more extensive material transfer agreements and IP protections for wastewater surveillance compared with more traditional environmental contract labs? Is this related to their academic origins? Is this a concern for the future of wastewater surveillance?
Carolyn, do you want me to take that?
I mean, go ahead and I can follow up.
Yeah, it's a good question. I have to say, within our interview set so far, this hasn't come up as a major piece of data, but it's something we are on the lookout for in these relationships. So this is preliminary findings, and it's something I think we're still looking into further. Yeah, Carolyn, do you want to follow up on that?
Yeah, I mean, I would just echo that, and this is going to look differently in different jurisdictions. And thus far, we've been looking quite broadly across a number of different countries and continental sites. And so this is certainly an area where our future research needs to go into looking at those kind of nitty-gritty jurisdictional issues around IP and material transfer agreements, et cetera. So yeah, thank you for that question. And if anyone has an experience with that, we would love to chat with you about that.
And just one follow-up to that, as qualitative researchers, utilities and private firms often don't want to share details of these material transfer agreements and IP agreements with us. In our research, Carolyn and I have done a lot of research on issues of infrastructure and sanitation throughout the world, and this is some of the first times that we've been asked to sign confidentiality agreements to do our research and work too. So that's also, it's a great question. It's one we're trying to drill into, but you could imagine that it's a hard one to get access to as well, the data.
Great. The next question is one that I was thinking about as well. As this from Rachel Paretsky. Where do you see the future of academic labs research in wastewater surveillance? I think many people here had the experience that we were the ones doing it early on, and now it's been a lot more commercialized. So.
Yeah, I mean, I can start, Carolyn. Do you want to?
I mean, I think, like, as we touched on in the presentation, I think a lot of labs have seen this as being an important intervention and giving back to the community, but also a lot of the people that we spoke with said that they did have to turn their research programs to doing this public health kind of work. And so I think part of this is a normative question as to what should academic research labs be doing and what sort of basic science do you folks who have been doing this work want to be doing? And I suppose the concern that we're outlining here is that when academic labs and university labs do it, they are essentially subsidizing what public health has historically been doing. And therefore, like, if you want to be delivering that service, maybe that's a good thing, but I suspect a lot of you want to be doing other things as well, or developing those technologies that can then be used by the public health system. So I don't necessarily have a future that we have laid out other than to say, this is what we think as people who value public health, we think that it should be the public sector who's doing most of that service delivery.
And just to add to that, I think as social scientists, one of our impulses is to try to contextualize some of the day-to-day questions that you're all asking kind of in the lab, at the utilities, in the public health departments, in a larger context. And what we noticed is that this demand on academic research labs was coming at a time where many of our universities were cutting budgets, many public health departments were cutting budgets, but we were also all pushed, for us and our grad students, to kind of do more applied policy partnership work, which again is not a bad thing. But as social scientists, we try to understand how those three different trends articulate together and create a situation where we may be kind of filling in gaps where the state would previously fund. And perhaps if we're interested in maintaining some control over kind of our basic science and our basic science research, maybe we won't accept kind of that new arrangements of the public-private sector in public health. Yeah.
Great. And maybe one last really quick one, and I'll combine a couple of the questions that were up there. How could we structure some of these contracts with private firms better to overcome some of these concerns? Do you have any specific insights or suggestions? That's a thread that kind of runs through a couple of the questions that are in there.
I mean, I think directly from our research findings, those three areas, clauses around protecting vulnerable communities in the prototyping of experimental technologies, even if the benefit seems kind of quite intuitive, I think we should have a higher bar there in those contracts, and that the benefits of any kind of intellectual property development are distributed in some way back to those that also bore some of the risk. This concern around kind of proprietariness and black boxing, as some of our interviewees said, I think is another one, trying to keep as many of the technologies and techniques in the public realm as possible. And that's not to kind of just like take profits from these firms, but so that this kind of continuing exciting innovation between so many different sectors can go on, right? Just like we saw in the beginning days of 2020. And yeah, I think those would be two major things. Carolyn, do you have anything to add?
I would just say that one of the people that asked that question in the chat has said, what could this include publishing these methods as a deliverable? Yes, like also thinking about different IP protections and when IP protections should potentially be, I don't necessarily want to say suspended, but that there should be other agreements in place during things like public health emergencies. So thinking about IP law, yeah, with forefronting some of those fundamental principles that Rafi has just noted, which of course is not an easy thing, but it's an important area of intervention, I think.
Great, thank you. So thank you again, Carolyn and Rafi. There's a few more questions we didn't get to, so I'm sure you'd be glad to address those in the Q&A box. And with that, I'll let Rolf do the introduction of our next speaker.
All right, thank you, Kyle. Wow, this was a fascinating talk. Thanks, Rafi and Carolyn. I'm sure there will be follow-up conversations about this. But let's use our remaining time to introduce Sílvia Monteiro. She is coming to us from Lisbon, Portugal. Is going to talk about tracing the circulation of dengue and chikungunya viruses using wastewater-based surveillance in a non-endemic county. Sílvia, take it away.
I'm going to try and share my screen and my presentation. Well, it will be really hard to follow up after this great talk, but I will be talking about, and I would like to thank for the opportunity to present our work here in Lisbon. I'll be talking about something that has been on the back of my mind for several years, the presence of arbovirus, so much so that we even thought of buying mosquito traps to look for them, but fortunately with this tool, with wastewater-based surveillance, we can do it without looking at the mosquitoes themselves. So vector-borne diseases are transmitted by vectors that, again, they can have impact in both humans and animals. And these diseases, as we know, are commonly referred to as vector-borne diseases. Why is this important to us? The climate is changing. We are traveling every day more and more each year. The countries are much more open to global trade. So with climate change and with all this, these are factors that may play a role in facilitating the migration of vectors and the transmission of these diseases to areas such as Europe that is not usually there is usually a temperate zone. So the vector-borne diseases can be transmitted by several animals, mosquitoes, ticks, snails, etc. But we were looking more into the mosquito-borne diseases. There are several species of mosquitoes, and we were really interested in Aedes, which is also called the Asian tiger mosquito, that can transmit several viruses, including chikungunya, dengue, Rift Valley fever, yellow fever, and Zika. Then we have Culex that can transmit West Nile virus, and Anopheles that is the mosquito responsible for the transmission of malaria. So why did we want to focus on vector-borne diseases and vector-borne virus in wastewater? Because many of the infections are asymptomatic or they cause mild symptoms that are similar to other viruses, and they can be detected in the urine of infected patients. The problem is when they don't cause asymptomatic or mild symptoms, and that they can cause very problematic symptoms, even death. So with that, we thought of looking into raw urban wastewater to detect and to see the trends of arboviral diseases in the community, especially in Portugal, that is a non-endemic country where there is not a lot of information and not a lot of cases. For instance, for you to have an idea, since 2015 until 2021, only 3 cases of chikungunya were detected in Portugal, and only about 100 cases of dengue were detected in the same period. So in our work, we have looked into 273 samples, analyzed every 2 weeks between May 2022 and April 2023 in 3 regions in Portugal, in the north, in the Lisboa and Val do Tejo region, which is the red region that you see here, and in the south. We had different numbers of wastewater treatment plants, and I cannot say where they are because they asked for to remain anonymous, so I cannot say where they are, but they were 24 hours composite samples. Oops. We use the method that we've been using since 2020 for SARS-CoV-2. So we concentrate 1 liter of water using hollow fiber filters. Then we precipitate overnight using polyethylene glycol. We extract the nucleic acids, and we detect dengue and chikungunya. We use 2 genes for chikungunya because we had so little cases of this virus in Portugal, and we normalized our results using crossfage because we didn't have access to the flow of the wastewater treatment plants. Our limit of detection was 2.05 power to the 3 for dengue, and 3.41 power to the 3 for chikungunya for both genes. We found that dengue was present in 68% of the samples, totaling a total of 25 samples, and chikungunya was present in 30% of the samples, 11 samples. In 68 samples, sorry, it was the other way around. So there was 68 positive samples, 25% for dengue, and 30 positive samples for chikungunya, with 11% of positive samples. If we discriminate between both genes, then we had 7% detection for both chikungunya genes. The load that we found after normalization with crossfage, it was pretty similar between both viruses. Looking at the samples and the positive samples, what we found was that from all the samples that were positive for at least one of the targets, 62 were positive for dengue, 24 for chikungunya, and then in 6 samples, both viruses co-occurred. This graphic shows the positivity rate that we found for CHIKV and dengue. So we had an increase in the prevalence of the virus in wastewater while we were entering the summer. here is September, and we had the peak of positive results in September in all of the different, not just in Portugal, but in the 3 different regions. And we only managed to detect chikungunya for the first time in December 2022. And I was very happy because all of the previous results were negative. And it was found in the Lisboa and Val do Tejo region here where I live. And a second detection occurred in January 2023. Then when we moved further into the spring, we found a higher prevalence of chikungunya in our wastewaters, including 100% of detection in the north and the south region, a little bit less in the Lisbon region, and also a slight increase in the prevalence of dengue in wastewaters. Looking into the load of the dengue, sorry, I didn't write here dengue. This is the load in dengue. We can see that we had a spike in the concentration near September 2023, and then another smaller spike starting in April 2020, starting in March and going through April 2023. And this is in accordance with what we see, for instance, here the first peak we have, the higher one, goes with the peaks that we usually have in Europe because it's the climate is favorable for the development of the mosquito and for the transmission of the virus. But this second peak here is not so common in Europe, and it's similar to the peaks we found in the South Hemisphere countries that are endemic. As you can see here, this is the total number of cases, and we see there's a spike in the first weeks of the year in all of the years, 2020, 2021, 2023 too. So the second peak is similar to this peak, and the same happened for chikungunya, where we had a peak just here in the after the beginning of 2023 that also aligns with the peaks that we find in the South Hemisphere countries that are endemic. So what happens is that Portugal receives a lot of tourists, particularly from Brazil, and they tend to travel more during our winter, so their summer, which is between November and March. And we receive like 16% of the tourism from Brazil comes to Portugal. It's only second to the United States. And we think that the tourists and also the Portuguese people that are traveling abroad to the countries that are endemic are bringing this virus with them. Looking into the different regions of Portugal, we can see that the virus, on the left side, we have dengue. On the right side, we have chikungunya. We can see that the virus follow more or less the same trends in all the 3 regions for dengue. In the case of, except for the south region, that we don't see the peak at the beginning of 2023 that we saw that we see in the north and in the Lisboa and Val do Tejo region. So it was a bit different. The south usually during the winter doesn't receive that much tourists. So this may be why we didn't find a peak in the dengue virus concentration. And for chikungunya, there was an explosion in all of the different regions following January 2023. Here, these 2 peaks are the peaks where we detected chikungunya in Lisbon in a single sample. But we can see that the behavior was more or less similar between the 3 regions. We looked into the seasonal distribution of the virus. We can see that the concentration of dengue, because it was the one that we found throughout the study, didn't change much between the different seasons. But if we look at the prevalence of the virus in the different seasons, we see a large difference. We see that in summer we had a higher prevalence of dengue in the wastewater and also in spring, and then it decreased for fall and winter. On the other hand, as we could see before, chikungunya had a high raise during spring. Almost 50% of the samples were positive for this virus, and in some locations, even all the samples were positive for it. And in summer, we weren't able to detect chikungunya. So to summarize, dengue we could find dengue throughout the study. It had slightly different behaviors between regions, and the prevalence and the concentration followed two trends. The first one more aligned with the Northern Hemisphere trend, with increased cases in the second part of the year, in the summer. And the second more aligned with what we see in the Southern Hemisphere, where we have endemic countries. For chikungunya, the first detection we had was in Lisbon, but the detection increased following January 2023. And CHIKV detection followed only the trends that we found in the South Hemisphere. So to conclude, the detection of viral RNA from a symptomatic, resident and transient population can be followed by wastewater, and therefore wastewater can be an important tool as a complement to syndromic and vector surveillance for arbovirus, in particular in a non-endemic country. Thank you so much.
Thank you, Sílvia. Fascinating. I'm glad to see this work here on not so common diseases that certainly have a lot of impact in other regions of the world. So let's take a look at the questions you received, maybe in order of relevance. The first one here came in asking about the sample matrix used, knowing that there can be difficulties in using straight wastewater. So did you use wastewater, sludge, supernatant? What exactly was your...
We have used wastewater. Actually, this work was done also in parallel with SARS-CoV-2 work. So we've been using this method that we developed since 2020, and it has given us very good results. We also use for the extraction. It's not that common, and many times we get questions by the reviewers about that. That we use a DNA kit that is for stools, so it removes a lot of the contaminants that are in the stools and therefore in the wastewater, and it allows us. It takes a lot of work, but it cleans the samples really well, and so we use an extraction control. I didn't put the extraction control in the presentation. I'm so sorry. To account to see for the extractions efficiencies, and so we are very confident in our method, and so we use raw urban wastewater.
Okay, thank you. Next question regarding the positive detects. Where do you think the signal is coming from? Is it from the mosquitoes? Is it from stool of infected patients? What do we know or don't know?
Well, it can come from mosquitoes. That could be possibly an explanation, although here in Portugal, we do vector surveillance, and so far there was never a detection of dengue or chikungunya in the mosquitoes. So I would say that it's probably from infected people, either transient people, tourists, or Portuguese people that go abroad and come infected, that contribute to the presence of the virus in wastewater. Of course, we cannot exclude the mosquito itself, but so far, all the tests that have been done in the mosquitoes didn't report the presence of the virus any of them in the mosquito.
Thank you. Let's see, what else do we have here? I think you touched on it, but maybe let's expound on it a little more. How many clinical cases were reported during the time period? And particularly, do you think that the clinical reporting is complete, or how complete is it, given that these are not very common diseases?
Well, that's a great question. And unfortunately, for the period that we've analyzed the wastewater, we cannot give you those results. Because the Portuguese health authorities are very closed, and they told us that we had dengue imported. All of them were travel-associated dengue cases, but they didn't tell us how much and how many, because they were still trying to close the previous year, analyzing the results. So I guess with wastewater, we could go there faster. and provide information that there are cases circulating to the population than the public health themselves. We know that there were cases of dengue travel associated, but they wouldn't give us the numbers because they were still analyzing. If we go to the ECDC website and we look for Portugal, they say that there was 0 cases reported in 2022. Because probably our health department didn't provide them with the report. So actually, we don't know that number, unfortunately.
All right, and then excellent presentation. There's some anecdotal evidence that dengue is shed in urine rather than feces. How might this affect the use of wastewater surveillance in comparison to the patterns we see with SARS and other diseases?
That's a great question. We've been looking for. This is not the first time that we are looking for virus that are excreted in the urine. There are many other viruses like GC polyomavirus and BK polyomavirus that are excreted in the urine, and they are detected in really high concentrations in the wastewaters. So we don't feel that there's a huge impact by being excreted in the urine rather than in the feces.
Okay. Let's see, maybe some technical questions here before we kind of zoom out and look at the larger health impact. What do you think about efficiency of Invi R180 hollow fiber filters instead of using common filtration filters? Very specific question. I'm not sure whether you can answer to that.
Thank you for that question. It's a great question. Actually, these filters, they have been designed especially for the beginning of the pandemic. We help Innovi is from Fresenius Medical Care, a large hemodialysis and clinical company, and we worked with them from the beginning in the development of not only with the filter, but also with how to do the elution. So we tested it against other methodologies, and it was very robust. And it allowed us, depending on the sample, of course, to filter between 2.5 and 5 liters of wastewater. So very robust filter. With great recoveries, as we could see. Regarding other filters, we've used them, but for wastewater, they are not as good as the Innovi filters.
Okay.
In our experience.
Thank you, Sílvia. And then here's a question about the data treatment. For the normalized data you presented, was the recovery control you mentioned used to adjust the data in any way?
Yes. We used crossfade to adjust the data because we didn't have access to the flows of the wastewaters, of the wastewater treatment plants. So we decided to use crossfade that we've also tested here before in our lab and provided results that are close to the normalization by the population and the flow. And we use it to take into consideration flow changes, dilutions, and it has been working very well for us.
Great, thank you. Maybe let's touch on sequence analysis. I mean, this was mostly focused on detection. I'm wondering whether you did any confirmatory sequencing on the positive samples, or if there were any phylogenetic studies done at all based on wastewater diseases.
Yes, we have sequenced the samples that were positive. We run the amplicons in an agarose gel. We cut the band and then we send it for sequencing, and we confirmed that what we were detecting were indeed dengue and chikungunya where we detected. About phylogenetic trees, it's difficult because for instance, for dengue, it was a broad assay. So it can detect dengue, serotype 1, serotype 2, serotype 3, serotype 4. So it's difficult to say, okay, it's this serotype, is that serotype, because since we don't have so many cases, we went for a broader assay rather than specific ones. But yes, we sequenced the product to see if really they were what we were detecting. Also, we did that previous job of looking into the sequences in silico using BLAST. We did in situ experiments against chikungunya, against the dengue assay, and also against other viruses that are commonly, and even bacteria that are commonly found in the wastewaters, such as norovirus, enterovirus, adenovirus, E. coli, to see if there was any cross-contamination.
Great. Thanks, Sílvia. I think maybe keep the last question here answered for everyone. And that's, you did this monitoring in a place where it's non-endemic. The question is, what would we find? Is there work ongoing to do this on a routine basis in the endemic places? And if so, what type of action you think, actionable information would come from it if we would implement it in those places that need it most?
I think it's very important because usually in many cases, the places that need it more are also the ones that have a higher probability of not reporting or not finding. And so I think it's like for polio, it's very important to look into surface waters or whatever they have there if it's an unsewered system. So I think it would be a great thing to do in those countries. So I think the answer is yes. I think it's even more important to them because many of them, of course, if we're talking about Brazil, they already know that they have a lot and they can try to control it. But if we're talking, for instance, countries from Africa, and some of them, and we work, for instance, in Mozambique, they don't test people that much. So it's important to know when to use these tools because for once they don't have that much money, and this is much cheaper if we're looking for a community. And so I think it's probably where it's most important.
Great. Well, thanks, Sílvia. Thanks for a wonderful talk. And also thanks to Carolyn. This was really a splendid hour of the day. I give it back to Ali to maybe make some announcements.
Thank you, everyone. That concludes our webinar, and we have another webinar in March where we will be hearing, we have two great talks. One from Joe Brown talking about work in low and middle income countries with fecal sludge, and one from a postdoc in Tim Julian's group talking about multiplexing 7 targets for wastewater surveillance. So we'll get those announcements out to you soon. Have a great day. Have a great weekend. Goodbye.
Thank you. Bye-bye.